that model is related to oligopoly. In case of oligopoly, I think you got some brief description of oligopolistic market in your first semester microeconomics course. So in case of oligopoly, there will be few firms under the industry. So it is not like perfect competition. It is not that number of firms will be there. And again, it is not like monopoly that a single firm will be there. Rather, there will be few firms operating in the industry. Now, oligopoly is a very interesting concept, So in your later semester, you will learn about different types of oligopolistic market. You will learn about game theory, okay? Because the issue of game is related to oligopoly. Actually, in context of oligopoly, firms behave strategically. So there will be different type of strategies, When firms are deciding output, I may decide my output thinking on the fact that your output is given to me. I'm understanding that I'm not the only person in the market or in the industry. So there are few firms. Okay. So when I'm taking my output decision, I'm considering the output of rest of the firms are given to me. So this can be one thing. Regarding price also, there may be strategy. Okay. Or regarding output, it may happen that I am behaving like a leader, rest of the firms are behaving like followers. So different strategic behavior will be there. So here it is not possible to discuss each and everything, because first you need to understand the theory, different theoretical aspects, and in that context, how the firms are deciding the output that you will learn to determine in your future course. However, in this mathematical course, I'll bring one model, one strategic behavior, the introductory chapter in the oligopoly, that is the Cournot behavior, Cournot game, Cournot kind of game. Okay, so you will get some idea about the strategic behavior. Here our objective is to write down the profit equation in context of oligopolistic market, and how in case of oligopolistic market, given the profit equation, we will solve for the different levels of output. Here our objective is to learn this part. So for that matter, we are bringing or we are introducing oligopoly from that angle. Yes, Richie, later I'll mark you. So following that objective, here we will learn how to write, or how we can write the profit equation in context of strategic behavior. We will learn to solve the profit equation in two ways here. If individually firms take decision in the market, how we will write the profit equation and solve for the output. Or it may happen that firms together are taking some decision, and then profit will be distributed evenly among them. So it can be joint profit maximization, or it can be the profit maximization at individual level. So first, we will talk about how firms will maximize profit at individual level, and then we will learn how jointly also the profit can be maximized, and that profit can be shared among the firms. Okay, so in context of joint profit maximization, today I'll introduce a new term, cartel. Okay, the term is cartel. Okay, so one by one, let's discuss all these points. Now, as I mentioned, in context of oligopoly, there will be few firms under the industry. Now, again, to keep the analysis simple, what we need to have more than one firm. Okay, one variable case, one variable optimization you did in your last mathematical economics course. So here we are doing something where we have more than one. So to keep the analysis very simple, under all circumstances, be it price discrimination, be it multi-plant monopoly, be it multi-product firm. We are considering two variables at a time. So here also, in context of oligopoly, we are considering two firms. There are two firms in the industry. So two firms produce identical outputs and sell into market with the linear demand function. P is equal to 100 minus total output, 100 minus Q1 plus Q2. Since we are talking about two firms, instead of calling it oligopoly, we are calling it duopoly framework, duopoly. So this is the aggregate market demand. P is equal to 100 minus Q. This is the aggregate market demand. To keep the entire presentation very simple, in the introduction, we are considering as if firm's production cost is zero. However, when we will go for the numerical exercise, we will bring the cost equation too. Now, to begin with, we are considering the cost is zero. The cost part is zero. Okay. So each firm wants to maximize profit given by pi I is equal to P into QI. So look at the profit equation. Here there are two equations, pi 1 and pi 2. So I'm writing it pi I. Pi I is equal to P into QI. Now, if I consider the cost equation, in that case, pi 1 will be P into Q1 minus C1. That is the cost of producing the output by the first firm. And the profit equation for the second firm will be pi 2 is equal to P Q2 minus C2. So cost will be the function of output produced by that firm. So it will not be a function of Q1 plus Q2. Okay. So it will be C of Q1 only or C of Q2 only. Okay. So later when we will bring the cost part, when we will go for the numerical exercise, you will find that I am subtracting C1 in case of firm 1 and subtracting C2 in case of firm 2. Okay. However, it is interesting to check that, here the profit equation is not the total profit equation. It is the profit equation for firm 1 and firm 2. So I is equal to 1, 2. I is varying between 1 and 2. Now, if I start with the specific demand equation, specific demand equation, in that case, my demand or P will be given by this. P will be given by this. So this will be multiplied with QI. So 100 QI minus Q1 plus Q2 into QI. So another interesting point to note, when I am taking my profit decision, my profit is not only function of Q1, but also function of Q2 as well. So here there is, this QI will be replaced by Q1, and this QI will be also replaced by Q1. So essentially Q1 is there. However, it is not only a function of Q1, it is a function of what you are producing too. Okay. So it is function of output of other firms operating in the industry too. Okay. Now, if anybody has any problem, I'm writing the equation. In the P equation, I have this is my P equation. So when I'm multiplying it with Q1, I'm getting this one. So pi 1 is a function of both Q1 and Q2. Similarly, pi 2 will be also a function of both Q1 and Q2. Okay. So we can write Each firm's profit depends on the total output of two firms. That is, each firm's profit depends on how much output the other firm produces, as well as on its own output. This form of close dependence is the characteristic of oligopolistic market. Okay, this kind of dependence, my output decision will depend on your output decision, though I am maximizing my profit. Okay, though I am maximizing my profit, my decision of profit maximization will depend on your decision of profit maximization too. So there is close dependence in the characteristics of the oligopolistic market. The difficulty the firm faces to determine its own profit maximizing output, as the firm has no knowledge about what the other firm is producing, because individually everybody is maximizing the profit. Here, Kurno assumes that actually this is the point when all the models differ. So you have no knowledge about what other firm is producing. So here you will bring different issues, different types of assumption, and that will make your model different. Kurno makes a kind of assumption. Stackelberg will make another kind of assumption. Okay, so there are different models where the assumption will vary regarding my perception of profit maximizing output of others. Okay, so regarding the perception, it will vary, the models will vary, and therefore we call it, there are different types of strategic behaviors in context of oligopoly. Okay, so firms can take different types of strategy depending on what kind of model we are going to build up. So here Kurno assumes that each firm takes the output of the other as a given parameter when choosing its own output. Okay, so I'm considering your output as a given parameter to me, and with respect to that you can produce this amount or that amount, a range I am thinking about. So if you produce this amount, I'll produce this. If you produce second amount, I'll produce this. So in this way, we will move in context of Kurno model. So I am considering your existence, and I'm considering the fact that you are also profit maximizing. Now, for different possible levels of your output, considering your output may vary between this range, I am taking my profit maximizing decision. The market equilibrium is given by the solution of pair of simultaneous equations. Okay, market equilibrium will be given by a solution of the pair of simultaneous equations. Finally, if you produce 5, I'll produce 6. If you produce 3, I'll produce 10. If you produce 10, I'll produce 5. So all these different possibilities will be there. And from all these possibilities, how we will find out the equilibrium amount that we will like to learn. Okay, so there are a range of possibilities. From this range of possibilities, how using strategic behavior, we will find out the equilibrium solution that we are going to discuss. So if we maximize, yes.
Ma'am, actually in real life, if the cost is not assumed to be 0, then the cost will be different, right, from for the different firms.
Yes.
Okay, ma'am.
Yes, I told you to keep the model simple. Now I'm going for this. However, I mentioned so many points, Anandarupa, regarding the cost. I mentioned that in the profit equation, pi 1, I'll bring C1. In the pi 2, I'll bring C2. I mentioned the things.
Yes, ma'am. Yes, ma'am.
Ma'am, is there a reason that the profit maximization of one firm depends upon the output of the other firm too? Like the
Could you please
Yeah,
repeat the
so,
question once more?
ma'am, is there any like intuitive reason why the profit maximization of firm 1 depends on the output of firm 2?
Because there are, in context of oligopoly, in reality, under only a very few contexts you can have monopoly. And again, perfect competition is another ideal kind of situation. So many buyers, so many sellers, perfectly elastic demand faced by the producers. All these are only few examples you will be able to provide. Under most of the circumstances, if you think about an industry or market, there will be several firms operating in the industry. The number is not numerous. Again, the number is not one. So under most of the circumstances, you will get oligopoly actually. Now, if you know that there are few rivals in the market, this is the challenge. How, given the fact that there are rivals in the market for your commodity, how you will decide your own optimizing level of output. Okay, so this is the intuition. You know the fact that there are several other firms operating in the market. They are producing similar kind of commodities. Okay, so how you will accommodate the other firms in your profit maximizing decision in context of oligopoly, we are learning that. It is the fact that you know that you have the information that you have rivals in the market. You know that there are several wristwatch producing companies. There are several toothpaste producing companies. Okay, so there are several greetings card producing firms in the industry. So given the fact that you have rival, monopoly and perfect competition are very extreme situations. However, oligopoly is a natural situation. You know that you have rivals. So the challenge is, given this information, how you will set your profit maximizing condition, how you will find the solution, optimum solution. Okay, got the point?
Yes, ma'am. Thank you.
If we maximize firm I's profit, okay, treating the other firm's output as given parameter, we obtain for two firms the two equations. I have P into QI. That means PQ1 and PQ2. Two equations are there. You know, pi 1 and pi 2. So if we maximize firm I's profit, either firm 1's or firm 2's, the other firm's output as a given parameter, considering or treating, it is the Cournot assumption, treat other firm's output as a given parameter. Here I can consider other assumption too. If instead of Cournot, if I consider the Stackelberg's model, it may happen that one firm is behaving like a leader. There are several other firms in the industry. However, they are behaving like a follower. That is, one firm will decide how much it will produce. It has immense power. It's the leader. Because of many reasons, leader appears. Now, leader cannot, many a times it is found that leader cannot produce or cannot meet the entire market demand. Leader may not be able to meet the entire market demand. Okay. So in that case, there will be several other producers too who are behaving like followers. Whatever rest of the demand will be, in the market, that will be shared by several other firms. In toothpaste industry, you may think about Colgate may be considered as a leader. Still, Colgate has more capture of the market compared to the other producers. In case of biscuit, maybe Britannia is the leader. However, you will find nowadays maybe Bisque firm is selling more than Britannia. It may happen. Okay. However, you know, apart from this leader, or when there is leader, it may happen that the leader cannot meet the entire market demand. Okay, so leader can produce how much it want to produce, you know. However, there will be some more demand. So that demand may be shared by other firms. So that may be another type of behavior in the market. So there are different possibilities. You know, the entire game literature, game theory is based on these strategic behavior, different types of strategy. Strategy may be in terms of quantity, strategy may be in terms of price. There is Batra model. In Batra model, the strategic variable will be price. In terms of price, Batra presented the strategy, you know, because here the firm has some market power. Market power will be lesser than that of the monopolist. However, the firm has market power. So there is model where price will be the strategic variable, and in terms of price, we will decide, you know, how much will be produced in the market or how much demand will be captured by a particular firm. Okay. So many a times you will get a big player. However, the player is not the monopolist. Look at the chocolate industry, look at the ice cream industry, you know. So there are big players that we understand. However, there are a few more. Are you getting my point?
Yes, ma'am.
There can be a market which is based on this kind of strategy. Okay. Different types of strategic game, strategic behavior. So here we are considering, or Kurnak is considering, other firms' output as a given parameter. And Kurnak goes for two profit maximizing equation. If there are three firms, we have to increase the number of first order conditions. Phi 1 will be function of Q1, Q2, Q3. Pi 2 will be function of Q1, Q2, Q3. And then there will be one del pi 3 by del Q3. Okay. So the number of equations can go on and on if there are n firms in the industry rather than two. Now, if I consider the Q2 as given, you know, and if I start with this equation, 100 Q1 minus Q1 plus Q2 into Q1, you know. So there is 100 Q1 minus Q1 square minus Q1 Q2. Okay. So these three things, 100 Q1 minus Q1 square minus Q1 Q2. So if I take the derivative, are we getting this equation from 100 Q1 100 minus 2 Q1 minus Q1 square, from there 2 Q1, and then there was minus Q1 Q2, from there we are getting Q2. Is it okay, the first order condition?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Following the same logic, if we consider the first order condition for the second firm, we will consider Q1 to be given. Both the firms are deciding in the similar way. The strategic behavior of both the firms are identical. So for second firm, Q1 will be the given parameter, and therefore when we consider the first order condition, we get 100 minus 2Q2 minus Q1 is equal to 0. So what do you have to consider in context of oligopoly? Separate profit functions for all the firms. However, these profit functions will be function of output of all the firms existing in the industry. So you have to write separate profit equation for all the firms. However, all the profit equations will be function of all output of all the firms. So remember this kind of equation. This is more important from the view of mathematical economics. Later you will learn about different assumptions, and for that matter, sometimes you will consider Q2 constant. Sometimes, first you will decide what will be my output, then the rest of the market will be shared. So there will be different things, but under all circumstances, all the firms will have different profit equations, and all these different profit equations will be function of output of all the firms operating in the industry. So that you need to remember. Now you will be, once you get this thing, these are two equations in terms of two unknowns, Q1 and Q2. So solving these two equations, you will be able to find out Q1 star and Q2 star. Solving these equations, you will be able to find out Q1 star and Q2 star. The price will be the common price at which the entire output can be sold. Price will be the common price at which the entire output can be sold. So you have to use the price equation given there. Okay, so putting the two output levels in the price equation was 100 minus Q1 plus Q2. So putting Q1 star and Q2 star there, you will be able to find out P star. So remember that in oligopoly, if your strategic variable is quantity, in that case, all the firms will decide on the quantity matter. Price will be the common price at which the entire market can be cleared. Okay, so no fight, no strategy with respect to price here. If the strategic variable is price, then you have to consider the strategy in terms of price only. Otherwise, price will be that price where the entire market will be cleared. Okay, so we are considering the thing in that way. Once we get all these things, the second order conditions will be checked, considering the second order derivatives of the profit functions. Okay, so I think I didn't do this. When I'll go for the numerical, I'll do that. I didn't consider del square pi 1 by del q1 square and del square pi 2 by del q2 square and the rest of the things. However, looking at the equation, all of you will be able to do. So would you please derive these things first and check whether the second order condition of profit maximization is holding or not?
Yes, ma'am, it is holding.
Yes, ma'am.
So first find out del square pi 1 by del q1 square. That will be minus 2. Then del pi 1, del q1, del square pi 1 by del q1, del q2. That is minus 1.
Yes, ma'am.
Okay. So if you use this thing, you will get that the first order, the second order condition holds. Similarly, from here to
Ma'am,
yes,
here you have written that each of the profit functions. So we will find the second order conditions for each of the profit functions separately, right?
yes.
Ma'am, but if I'm doing that, I'm getting the condition satisfied.
However, here you cannot find out del square pi 1 by del q2 square kind of thing. So you just consider the first derivative, If you consider the first derivative, then it will be fine. You can consider only pi 1, 1, that is negative. You can consider pi 2, 2, that is negative. Okay, Oyon.
Ma'am, so we will not go for that Hessian matrix. We'll directly use pi 1, 1 and pi 2, 2, right?
The first principal minor of the Hessian, that is also Hessian.
Ma'am, but then we are considering the profit functions means jointly, means we are using the profit function of the first firm.
Oyon, you are deriving only this, 2 is not the order. 2 is for the firm. Okay, actually for both the cases you are deriving H1, the first level. This is also the, Hessian can be of 1 by 1. No problem. Okay.
Yes, ma'am. Yes.
Now here I have to mention one more thing, in context of oligopoly. Here there is an important concept of reaction curve. Okay. Now from the first order condition, I can write the equation for the first firm given by Q1 is equal to 100 minus Q2 by 2. Equation is 100 minus 2Q1 minus Q2. So from this equation, keep Q1 in the left hand side, rest of the terms in the right hand side. Write Q1 in the left hand side, rest of the terms in the right hand side. Because when you are considering Q1, you are considering Q2 as a constant. Okay, so Q1 can be written as 100 minus Q2 by 2. Following the same logic from the second profit maximizing condition, that is from the profit maximizing condition of firm 2, I can write an equation given by Q2 is equal to 100 minus Q1 by 2. These are called the reaction curves of the duopolist, If I consider Q2 to be 3, my output will be something. If I consider Q2 to be 5, my output will be something. If I think Q2 to be, from my experience, if I find Q2 to be 100, my Q1 will be 0. So all these things are there. All the things are there. So from my experience, I have a guess about Q2 here. From my experience, I have some idea about Q1 here. So accordingly, I am setting my Q1 here. Accordingly, I am setting my Q2 here. Okay. So given you are producing this amount, I'll produce this amount. Given you are producing this amount, I'll produce this amount. So as if this Q1 is reaction to different levels of output of Q2. Similarly, for the second firm, Q2 is reaction to different levels of output of Q1. So these two lines are called the reaction curve. The first equation is the reaction curve of the first duopolist, considering the fact that second duopolist will maximize his or her profit. The first duopolist is deciding what will be his or her own profit maximizing output. So it is reaction to your action. The second equation is the reaction curve of the second duopolist, considering the fact that first duopolist will maximize his or her profit. The second duopolist is deciding what will be his or her own profit maximizing output. Again, here, this is the action and this is the reaction. So the firm 1 is taking some action. Against this, I am taking my action. So it is the reaction to your action. Okay, so considering Q1 along the horizontal axis and Q2 along the vertical axis, we can plot the reaction curves as follows. Okay, so this is Q1, 100 minus Q2 by 2. And the second one is Q2, which is 100 minus Q1 by 2. So let's first consider or concentrate on the first equation. Q1 is equal to 100 minus Q2 by 2. So when Q1 is equal to 0 in the first equation, when Q1 is equal to 0 in the first equation, Q2 will be 100. If you set Q1 is equal to 0 in the first equation, Q2 will be 100. Alternatively, if you set Q2 is equal to 0, Q1 will be 50. Am I right?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Consider this set only. So I'm getting 2 points, 0, 100 and 50, 0. Once I get 2 points, I'll be able to draw a line. Once I get 2 points, I'll be able to draw a line. A straight line can be drawn. So 1 is 0, Q1 is 0, and suppose this level is 100. Okay? And another point is Q1 is 50, so half of this stretch, say, and Q2 is 0, so along the horizontal axis. So what we can do, we can join these 2 points. Joining these 2 points, I'm getting reaction curve of form 1. This line is nothing but 100 minus Q2 by 2. Q1 is equal to 100 minus Q2 by 2. So this is the reaction curve of first duopolist. Next, the other equation was Q2 is equal to 100 minus Q1 by 2. This was the reaction curve of the second duopolist. Now, if you set Q1 is equal to 0, you are getting Q2 to be 50. So one coordinate can be 0, 50. Another coordinate can be 100, 0. So if I mark, 0, 50, Q1 is 0. This point, and another is Q1 is 100, Q2 is 0. So this point, say. So joining these 2 points, I'm getting the reaction curve of form 2. Okay, so this is and this is and where the equilibrium will take place, any idea?
33.33 at the intersection of the both.
Yeah. Mathematically, we are solving that point, When the 2 lines are intersecting each other, we are getting will be given by their point of intersection. So though we are maximizing the profit, actually we are solving the 2 reaction curves. Actually, when we are maximizing the profit, etc., and finding out the solution, actually we are solving the 2 reaction curves. So this is the equilibrium solution when the 2 lines intersect each other, 2 reaction curves intersect each other. So this is the equilibrium solution. This is the equilibrium solution. So, or in this way, actually we derive the equilibrium solution in the Cournot framework. This one. The flatter curve is the reaction curve of the first duopolist, and the steeper one is the reaction curve of the second duopolist. Is it right? I think
No, ma'am.
Is the reaction curve.
No, it's opposite.
Okay. In a Cournot model, both the firms maximize the profit simultaneously. The equilibrium is achieved when the two reaction curves intersect each other. Total output in this market lies between the competitive and monopoly output. So, given these two equations, as homework, you should derive the monopoly output and you should derive the competitive output, okay, and check whether the oligopoly output lies in between the competitive output and the monopoly output, okay. So please do this as a homework, that oligopoly output lies in between the competitive and monopoly output. Now oligopoly output means 33 1/3 into 2. That lies in between the competitive and monopoly output. As I mentioned here, I'll also talk about joint profit maximization. Sometimes instead of, because there is some uncertainty, there is a matter of guess, counter guess, so all these things are there in the Cournot context. If you produce this amount, this will be my reaction. If you produce this amount, this will be my reaction. Okay, so all these things are there. So to avoid the uncertainty, the firms may form a cartel. Okay, jointly they are taking some decision. Jointly they are taking some decision. Okay, so joint decision is called the cartel. And together may try to maximize the total industry profit or joint profit. The behavior of a cartel will be similar to that of a multi-plant monopolist. It is very, very similar to that of a multi-plant monopolist, because, as if I'm producing the commodity, but regarding the marketing of the commodity, there is as if a single market, jointly we are maximizing the profit, and then profit will be shared among ourselves. So the behavior is like a multi-plant monopolist. Separately or independently, I am producing my commodity. However, there is some joint decision that what proportion of the market will be shared by me. That is a joint decision. You can avoid uncertainty forming or framing a cartel, however, you will lose also something, some part of the profit, your capability may be higher, then also you have to produce, or you will be able to capture only that part of the market, which has been written in the MOU, Memorandum of Understanding. Okay, so cartel is a joint venture. I am producing my commodity using my own inputs, own plant. However, whatever or what proportion of the market will be shared, what will be the price, all these decisions will be a joint decision. Okay, so after the class, when you will get time, please Google for cartel. What is meant by cartel? Different examples of cartel. Why cartel formation is sometimes very important. When the market is very, very uncertain, why we need to form cartel. All these things we will get. Okay, so very interesting. So please have some look about cartel. Now for the mathematical economics purpose, it is nothing but a joint profit maximizing decision. So an example, assume a market where P is equal to 100. Okay, so I'll tell everybody to take pen and paper and start doing the things. Otherwise, we will not understand the matter, how the Cournot decisions are different from that of the joint profit, etc. That will be difficult to understand. So please write down the equation, market demand equation, P is equal to 100 minus 0.5 Q, where Q is equal to Q1 plus Q2. So write down the first equation. and then write down two cost equations. So I'm not considering zero cost. There are two cost equations. So please write down cost equations. C1 is equal to 5Q1 and C2 is equal to 0.5 Q2 square.
Ma'am, sorry to interrupt. Kritika this side. Can I be excused? I had mailed you.
Yeah.
Okay. Thank you, ma'am.
What that you are not there?
Yes, ma'am. Actually, the time got delayed, so I thought I'll join.
Yeah, definitely.
Okay. Thank you, ma'am.
Yeah. So right up to this, there are three equations, the price equation and C1 and C2 equations. First, we will solve these equations for the Cournot purpose, and then we will come for the joint profit maximization purpose. Okay. So one by one we will do so that the things become clear to all of us. So first write down, in case of Cournot duopoly, the profit maximizing conditions are given by pi 1. Pi 1 is equal to, write down this P. Within third bracket, please write down 100 minus 0.5 into Q1 plus Q2. Close the square bracket into Q1 minus the cost component. What is the cost equation?
Five Q1 plus 0.5 Q2 square.
From where 0.5 Q2 square will come for the first one?
5 Q1 only.
Okay,
Minus
yes,
5 Q1.
Only 5 Q1, not the second part. Second part is coming through P. Once you get this thing, please adjust the equation a little bit before taking derivative. This is pi 1. My cost, because I am not producing your output. I'm producing only my output. So my cost equation will come here. So please adjust the equations a bit. Please check whether you are also getting this thing. You take the derivative on your own. No need to follow me. Yes. This we will call equation number 1. So this is the reaction curve of firm 1. So everybody got this result?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. Yes.
Will you agree? This is the reaction curve of firm 1. Okay, so this is the next, write down pi 2. What was the cost equation?
Ma'am, 0.5 Q2 square.
Please do on your own and please check whether the values are same to you.
Yes, ma'am. They are the same.
And
Yes, same.
for understanding, this is the reaction curve. Of duopolist 2. Okay. So once you get these two equations, equation 1 and equation 2, you need to simultaneously solve the equations. What you can do, you can substitute the Q2 values in equation 1 and you can find out Q1. And once you get Q1, putting this value in equation 2, you can find out Q2. So please derive the values Q1 and Q2.
Ma'am, for me, Q1 is coming as 80 and Q2 as 30.
I think there is a mistake. Let other people do the things.
Ma'am, 80-30 only.
80-30.
Yes, ma'am.
আমার একটু আলাদা ভাবে করতে হবে। Okay, since 2 people got this thing, so that will be the right answer. So,
Yes, ma'am, 80 and 30.
okay. Okay, and what will be the price?
Ma'am, it will be 45.
Okay, so this is the Purna profit maximizing behavior. Next, we will go for the same problem, we will go for the joint profit maximization. Okay. Rest of the students, are you getting these values? Could complete the thing. If there is any, please ask me for the Purna part. Sajid, could you do this thing?
Yes, ma'am.
Getting the same result?
Yes.
Anandarupa got this result?
Yes, ma'am. Yes, ma'am.
And you are understanding why we are considering the cost of that firm only?
Yes, ma'am.
Very good. So next we are going for the joint profit maximization case. Instead of taking the individual decision, suppose these two firms are framing or forming a cartel and trying to find out their profit maximizing level of output, etc. So in case of joint profit maximization, we have to consider a single profit equation. So here we will subtract in this way because it is the joint decision. Okay, so we will consider this kind of equation. Price is there multiplied with the entire quantity minus C1 minus C2. This kind of thing. Now the P equation here is given by C1 is, what was C1? C1 is 5Q.
5Q1.
Okay, so simplify this equation first.
Yes, ma'am, got it.
Got the results, final result.
For joint profit?
Mhm.
Yes, ma'am, almost. Like I'm doing the calculations.
Yeah, please. Let's first write the simplified equation. Please check whether I have any mistake or not.
Ma'am, I got this result only.
Yes, ma'am, this one only.
Okay. So once we get this thing, del pi by del Q1.
Yes, ma'am, del pi by del Q2 and then accordingly.
Yeah. And then simultaneously solve the equations and find out Q1 and Q2.
Ma'am, is it 90 and 5? Q1 and
Yes.
Q2?
Yes.
Yes, ma'am. Got the results.
It is 95 minus Q1 minus Q2 is equal to 0.
I also got 90 and 5.
Okay. This is 100 minus 2Q1 minus, no, sorry, Q1 minus 2Q2 is equal to 0. So it will be Q1. Solving these two equations, as you are telling, $90.
Yes, ma'am. And Q2 is 5.
Previously it was 80-30. Now you are getting it is 95. And what will be the price?
52.5.
52.5. Okay, so hence the joint profit. What is the volume of profit? Please check that.
4525.
4525. And in the previous case, what is the profit? Total profit. First, you can find out the profit of a single firm that you know, or separate, because separately you have to do. Find out pi 1 plus pi 2 in the earlier case.
Ma'am, it is 3200 and 900, which means total 4100 for the previous case.
4100.
Yes, ma'am.
This is absolutely fine, you know. So when they are, going for individual level profit maximization, their profit is lesser compared to the joint profit maximization case. Always you will get this thing, you know. However, if you look at the output solution, in the first case, you know, the second firm is producing 30 units, the first firm is producing 80 units, you know. So on the whole, in the market, there will be 80 plus 30 units of commodity. However, when they are going for the joint profit maximization, the total output that the customers will get, that is 95. Now, if you look at the problem from the firm's viewpoint, the profit is higher in case of joint profit maximization compared to this amount, you know, compared to the profit which the firm are gaining at individual level when there is the Kurno context. Okay, so each of the model has different aspects. In case of joint profit maximization, there is less uncertainty and, you know, higher will be the volume of profit under all circumstances. Whereas, you know, in case of Kurno model, this is a strategic behavior. Your output decision will be something else, and therefore the profit decision will be something. So this is all about the Kurno context and the joint profit maximization case. So everybody could come up to this, could solve the problem.
Yes. Yes, ma'am.
Okay, so we got these answers. So there is one more exercise here. Okay, this one. So try to complete this problem. You know, similar kind of thing you try to find out. first you find out the Cournot equilibrium, and then you try to find out the joint profit case. What will be the output levels if the firm go for the joint profit maximization? Answer is given here, so check whether you are getting this answer. Under the joint profit maximization case, here you will find Q2 star will be equal to 0. However, this doesn't matter to the firm because the profit volume will be higher and the profit will be shared among the firms. Okay, so all these things will be there. So please find out the solution, and next day we can discuss the matter. Now, some people asked me, if they want to take printout of the soft copies, what will be the chapters, etc. So from Chiang, you can take printout of 11.6 section from chapter 11 and the entire chapter 12. Actually, I'm telling you the entire matter. 12 is the constraint optimization. For unconstrained n variables, 11.6 is fine. And from the book by Hoy, you have to take printout of chapters 12, 13, and 14. Okay, so these are the chapters. Now, once we complete up to these different kinds of examples, when applying or considering different types of markets, in the next step, we will go for indirect value function approach. Indirect value function approach. Indirect value function approach. Now, what is this indirect value function approach? Today, I'll be able to give you only the introduction. This problem is complete, I think, so I can erase this one. Am I right?
Yes, ma'am.
Indirect value function. Now, what is indirect value function? Once we get the optimum values, we call the function as indirect optimum function, indirect value function. For example, as long as pi is a function of Q1, Q2, we call this the objective function. And we try to maximize it, taking derivatives in terms of Q1, Q2, etc. Now, once I get the optimum values of Q1 and Q2, I get pi star. And this Q1 and Q2 are, say, functions of L and K, labor and capital, or input prices, whatever be the thing. In terms of input also, you can write the function or you can have the function. In terms of input prices also, you can generate Q1 star and Q2 star. Suppose Q1 and Q2 are functions of L and K. On the basis of optimizing level of L and K, you are finding Q1 star, Q2 star. And once you put these values in the profit equation, you are getting pi star. So once you get pi star, which is a function of Q1 star and Q2 star, and Q1 star and Q2 star are function of something else, this is called the value function. Okay, or indirect objective function. this term indirect is coming along with the objective function. Okay. Now from this indirect objective function too, we can generate the input demand function, the output function, etc. So I started with the objective function and reached at pi star. The alternative approach may be I'm starting from an optimum and then finding the input demand function. I'm starting with pi star and then I'm trying to find out L star and K star. Okay, so this may be the approach. I'm starting from an optimum profit, and from that profit equation, I am deciding what will be my input demand. Okay, so this will be our approach. This will be approach. We are starting from an optimum function. We know that this optimum is a function of several optimums, which are a function of L and K. So from using this function, how we will derive L star and K star values, that we need to learn. Actually,
ma'am, how is Q1 star a function of L and K, ma'am? Should it not be the function of the parameters R and W?
Oyun, what is your question?
Ma'am, I was saying, why is Q1 star a function of L and K? Should it be the function of
output
the parameters?
Function of inputs?
Ma'am, the function of parameters, because at the optimum will change when we change the parameters.
Output can be function of inputs or not?
Yes, ma'am.
So output can be function of inputs, isn't it? So we can write it in different ways, no problem. We can write it function of W and R. We can write it as a function of L and K, or I can write the profit function in different ways too, you know, in terms of revenue and cost we did the thing. So I could write it simply as a function of Q. So I can write the thing in different way. Okay. Now I am introducing the problem. Try to understand what is meant by indirect value function, you know. So in the later dates, we will check how Q is becoming a function of inputs, or, you know, it can be a function of costs. I can, instead of Q1, Q2, I can consider other values as well. So these are the different things. The main thing which you need to understand, that is, henceforth, we will try to look at the problem from different angle. We have an optimum function, and from that optimum function, we will try to find out the values of several variables. So I considered pi as a function of, say, x1 and x2, and x1 and x2 are function of several things. So now those several things, or the values of those things, we will like to find out using the optimum function. Okay, so many are
basically they are indirectly related, not directly related.
indirectly related. Yes, this is the indirect objective function. Using the indirect objective function, how we are going to find out different economic variables or optimum values of different economic variables, that we need to understand henceforth. Okay, so this I want to tell you. What will be the function? What will be the exact nature of the function? These we are going to learn. Okay, to understand this, first here in the slide, I presented the input decisions of a firm. However, you did a numerical exercise based on this kind of thing. Okay, numerical exercise based on this kind of thing. Okay, I think you can remember in a class we solved this problem. Just a minute. This equation. Solve the competitive firm's profit maximizing use of labor and capital for the case y is equal to this, p is equal to this, w2, r4, etc. So on here output is a function of labor and capital, isn't it?
Yes, ma'am.
So already we did this numerical exercise in the class. So if I send this slide to you, I hope everybody will understand this. This is the piece from Chiang. So from Chiang also, you will get the thing. Already you did all these things on your own. So if the profit equation is written as total revenue minus total cost, this can be presented in this format, PQ minus WL minus RK, where P is the price, Q is the output, L is the labor, K is the capital. You know, price, W and R are considered as the parameters of the model. L and K are the two variables, labor and capital. And using these two equations, we derived the value of L star and K star. Okay, using the first order conditions, we can derive the values of L star and K star. L star will take this kind of value and K star will take this kind of value. So this is the usual approach. We will consider the profit equation to derive the input demand, say. We will consider the profit equation, and from the profit equation, solving for the profit maximizing, etc., we will derive L star, K star. Henceforth, and then we will be able to derive Q star as well. And as we get Q star, given price and W and R, we will be also able to find out pi star. So this was the approach up to this point. Now our approach will change a little bit. We will consider the optimum profit function, which we also call the value function. And from that value function, we will try to find out L star, K star. So it is given that this is my profit, and given this is my profit, I'll decide how much labor I'll employ, how much capital I'll employ. Okay, so this is another approach. This is the indirect approach. Okay, so today I'm just giving the introduction. So today, try to learn up to this slide, you know. So next day, I'll introduce the problem and I'll show you how using indirect value function, we can derive the optimum values of the inputs. For different economic variables, we can do these things. However, we will start with the profit function, and from indirect profit function, how we can derive the input demand functions. Because at this level, this is the most important economic problem we will be able to solve. Rest of the problems are related to constraint optimization. Okay. So I'll start with this problem. Any question up to this? From indirect value function, we will be also able to find out the Q star. What will be my output decision? What will be my input decision? Everything we will be able to find out, both the output decision and the input decision. So do anyone have any question?